Before we really start using pointers, we have to be aware of how we can use them. So in this session, we're going to look at expressions, operators, and arithmetic that we can do with pointers. Let's do a quick review of what we talked about in the last video. So first of all, it's important to remember that all a pointer is it's an address. We're using it for indirect access to another variable. In order to declare them, we need to specify the data type, we need the indirection operator, and the name of the pointer. So here we declared a pointer to a character. We called it ch pointer. To initialize or assign, we use the address of operator, so we can assign it to null, or we can assign it the address of a variable. So here we can see ch pointer assigned null, which means it's not pointing anywhere yet. And here we're assigning it the address of a character. And then finally, to get at the contents of, we use the dereferencing operator, and we say the contents of that pointer is assigned some value. So we could assign it to somewhere else, or we can assign it particular values. Here we're saying the value, or the character n, is going to be stored in ch, which is where our character pointer is pointing. So where can we use pointers? So these are called pointer expressions. So we can use them in arithmetic, we can use them in assignment expressions, and we can use them in comparisons. So let's take a look at these. So first, here we can see that our pointer is on the right-hand side of our assignment statement. So here we're saying sum is assigned the contents of pointer plus whatever it had before. So this particular line would be equivalent to sum is assigned sum plus the contents of pointer. So we can see this is just a normal arithmetic, except here we're using indirection instead of direct access to the contents of a variable. Now if we look at our second one, we have another assignment statement here. We're not doing arithmetic, well, we are doing arithmetic. We're doing multiplication this time, but this time our pointer is on the left-hand side. So here we're assigning it a value. So we're saying take value, take multiplier, multiply those together, and the answer to that arithmetic is going to be stored where pointer is pointing. So remember, we have our pointer, which has an address. It's pointing somewhere else. So the result of our multiplication is going to go in here, not in pointer itself, but in where pointer is pointing. Then finally, we can do comparisons. So we can say if the contents of pointer is less than limit, what that means is we're checking this guy over here and saying, is that value less than our limit? Okay, so we can use it in arithmetic, where the value is on the right side. We can use it in assignments, where it's on the left, and we can have it as part of any comparison instruction. It's very common for us to use pointers when we're working with arrays, and you can see we have a very small array here. It's got 5 elements in it, and we have specific pointer operators that make that job easy. So the first of those is our increment and decrement operators. So we can see here that we've got a pointer called v pointer, v for vector, and here it's saying vector pointer plus plus. What that means is if my pointer is here and I do vector pointer plus plus, it will move to point to the next element. The nice thing about C is it doesn't matter what kind of element is in that array. If I use a pointer operator to move that pointer, it will automatically go to the next element in the array. So a float is a different size than an integer, is a different size than a character. The pointer operator doesn't care. If I use the decrement operator, as I have here, it would move it back to here. So it will go back one element. So it's a very, very easy way to move forward or backward in an array. Now I can also use plus or minus. And so what it says here is if my pointer is pointing to the 11, the first element in my array, and I say move it by 4, it's going to go 1, 2, 3, 4 elements, and now it's going to be pointing to the 15. If I say v pointer minus equals 2, take 2 addresses away from it, it's going to, assuming it's starting here, it's going to go back 1, 2, and now it will be pointing at the 13. I can also subtract one pointer from another. So if I have 2 pointers, let me clear away some of this here. If my first pointer is pointing to the 15, and, well, let's call that our second one, and my first one is pointing to the 12, so I have v pointer pointing at the 12, v pointer 2 pointing at the 15. When I say v pointer minus v pointer 2, it's going to tell me that there are 1, 2, 3 elements between those. So it will actually count how many elements there are between the two things. So these 3 abilities are very useful to us. Being able to increment and decrement our pointers, being able to move elements away, or being able to find out how many elements there are between where we are and where we want to be. When you're using these pointer operators, it's very important that you understand the order in which they're going to get executed. To do that, you need to go to your order of operations table, which you'll usually find in the inside front or back cover of your textbook. So please make sure you take a look at this. What we can see from here is that the post, decrement, and increment are right up at the top of the order of operations. That means they're going to get done before anything else. The only thing that takes precedence over them are brackets, and we can see the few here. So round brackets, square brackets, a dot, and the arrow, which are field things. Now, if we look at where our dereferencing and address of operators come, they don't come down until the next line. So that means we have to make sure that when we're looking at these operations and how they're going to work, that we pay attention and know that our post and increment and decrement are going to happen before we get the contents of things. So just keep that in the back of your mind as we move forward. That said, it's pretty important also that you note this down at the bottom, which says that the post, increment, and decrement are delayed. So if we have an example, and the example they give is y is assigned x times z plus plus, and it says the current value of z is used to evaluate the expression, and z is incremented after all else is done. Seems to conflict with what we saw up here, but this note is actually the way it operates. So let's take a look at some of the common operations. The one we've been using up to this point has been the contents of our pointer. So that's going to allow us to get at the contents. What happens when we start putting our post decrement? Now, the rules, the chart says this would happen first. So we'd increment the pointer and then get the contents, but the post decrement is actually associated with this. So we're getting the contents of, and then we're moving. So that was that little note at the bottom of the table. That is in contrast to this one. So here, the increment is associated with the contents of. So the brackets do take precedence. So we say the contents of the pointer is what's incremented. So make sure you're clear about the difference between accessing and moving a pointer and changing what's being pointed to by the pointer. This is a place where brackets are your friend. As I mentioned at the beginning of the video, pointers are often used with arrays. And the reason that is because the array name is actually a pointer. and it would be considered a constant pointer because it always points to that first element that you're going to find in your array. Because of that, we can use array subscripts the way we've been doing it so far, or we can use pointers to get at exactly the same information that's stored in our array. Now, which do you do? That would depend on the circumstance. So the compiler itself actually converts. If you write it using array notation, it's actually going to convert that to pointer notation internally. So if you program it with pointers, it actually saves a little bit of compile time. That's not a really big issue these days with the speed of machines that we have. When we program with array structures, it makes your code readable. So people will know you're using arrays, but as you start to look at code written by people who are expert programmers, they will very rarely use array notation. They'll use pointer notation when they're working with arrays. For now, I'm going to get you to use pointer notation so that you experience it. We're going to use it when we start talking about dynamic data in a later unit, but it's important that you be aware that they are equivalent. So let's do a comparison of array notation and pointer notation. Let's put them on the same paper, look at all the options, and choose the ones that are most appropriate. Let's start by looking at the declarations that we did before. So here we have an array called v, holds 10 integers. Then we declared a pointer to an integer, which we're going to use to allow us to access elements inside our array. I've shown 5 of the 10 elements here. Then what we've done is we've looked at the 2 different ways that we can make sure that our pointer is pointing to the first element in our array. So the first method is to assign the name of the array to the pointer. The second is to say, give me the address of the first element. So remember, those 2 were equivalent statements. Now let's look at our arrays. So here we have our standard array notation that we've been using. So if we look at v with an index of 0, we're going to get the 11. If we use v with an index of 3, we're going to get the 41. So this should be very familiar notation to us now. But because we've done the assignments up here that we did, and our pointer, v pointer, is now pointing at that first element, we can actually say v pointer element 0 and get that 11. We can say v pointer element 3 and get the 41. So that's something that is possible, but let's mark that as a don't go there. If we're going to use arrays and we're going to declare them like this, let's use standard array notation to access the elements. If we look at the pointers now, our pointer is v pointer. So let's focus our attention on this second column over here, and if we're going to use pointer notation, let's make sure we're using it with a pointer. So here we're saying v pointer plus 1, so that, remember, the arithmetic takes us to one more element, so that's going to get us the 21. If we say v pointer plus 3, v pointer is here, we go 1, 2, 3 elements farther, we're going to get the 41. So if we're going to use pointer notation, let's use our pointer. Now, it is valid, because of the assignments that we've done up here, to say v plus 0, because v actually is here. v plus 1 would get us there. So it's possible, but again, let's not go there. If we're going to use arrays, let's stick with array notation. If we're going to use pointers, let's stick with pointer notation.